this presentation, I'm going to introduce you to a new data structure, which is the AVL tree. So AVL tree is basically a self-balancing binary search tree. So the only prerequisite of this data structure is that you should know what exactly is a binary search tree. And I've covered the binary search tree data structure in the previous tutorials. I will drop the link in the description below. So let's start with the self-balancing binary search tree. So this is you can divide this whole term into two terms, which is the self-balancing and a binary search tree. So self-balancing, let's study what is the meaning of self-balancing. So balancing basically means that if I want to say that a tree is balanced, or I'm going to write balanced binary tree. So according to the definition of balanced binary tree, the left subtree, the left or the height of the left subtree and the difference of the height of the left subtree and right subtree should always be less than equal to 1. So this is the basic meaning of a balanced binary tree. So self-balancing means that if you will perform an insertion operation in such type of binary search tree, you will essentially get a height of log base 2n. So here comes a new important concept, which is the height of a balanced binary tree. And if the height of the balanced binary tree is log base 2n, then we can say that it is self-balanced. So that's the basic idea behind a AVL tree. It is a self-balanced and a binary search tree, and we know that binary search tree is a tree in which the key of the left node is lesser than the parent, and the right node has key greater than the parent. So left key should be less than equal to the parent node. So this is basically a definition of the AVL tree, and the main reason why we use AVL tree because it has a height of log base 2n, and thus it will give us a time complexity of log base 2n in most of the operations like search, insert, delete, etc. So let's study a very important concept, why the height of a balanced or a self-balanced binary tree is log base 2n. So we are going to study this concept now. So I'm going to draw a binary tree here. So let's suppose we have a binary tree like this. I'm just trying to make some nodes. So if we have a binary tree in this form, you can see that this node, at this point, the height of the tree is equals to 0. At this point, the height of the tree is equals to 1, and at this point, the height of the tree is equals to 2. So you can see that at height 0, we have 1 nodes, which is 2 raised to the power 0 nodes. So I can write it like this. So there is only one element at height 0, so I can represent it as 2 raised to the power 0. So at height 1, I can write 2 raised to the power 1, which is 2 nodes, and at this point you can see the height is 2. So there are 2 raised to the power 2 nodes which evaluates to be 4, and this sequence will go on and on till 2 raised to the power h is equals to n. So we have got another equation from this representation and this concept, which says that if I want to find the number of elements at any height, I will just take the exponent of the height. 2 raised to the power h will give me the number of elements at that height. So this is an exponential form. I can convert it into logarithmic form or into the log form. So the log form will be log base 2 of n is equals to h. And this representation, you can see that this conversion can be understood by using this very basic concept. If 3 square gives you 9, you can represent it as log base 3, 9 is equals to 2. So you can use this simple example to convert this form into this one. So in this manner we have covered just the introduction of AVL tree. Then we will in the next tutorial we will cover how to insert in a AVL tree, and we know that after insertion the whole data structure or the tree that we will get should be balanced, which is the essential meaning of self-balancing. So after insertion or deletion operation or any other operation we are performing on a AVL tree, it will be self-balanced. And basically self-balanced means that the difference of the height of the left subtree and the right subtree will be less than equal to 1, or in simple words you can write that the height of the tree will be log base 2n. So this is basically just an introduction, and this is part 1 of AVL tree. So if you have liked the video, make sure hit the like button and subscribe our channel. So thanks for watching.